Hello everyone, JCE Connect. I welcome you all for this particular lecture. So in this particular lecture, uh, I'll be solving a problem on design of tension members, and here the problem considered as angles on opposite side of a gusset plate. That is the two angles provided on opposite side of the gusset plate. So in previous lectures we have seen the single angle connected to the gusset plate. Here the arrangement, this is the angle, double angle considering on the opposite side of the gusset plate or back to back angles are provided. The angle section is 75 by 75 by 6. This is the arrangement of bolts given. There are 5 number of bolts are given, and edge distance is mentioned here 35. Pitch is given as 50, that is a 4 number of pitches. Then the length of uh, bolt line from the first bolt hole center to the last bolt hole center is marked as a LC. So this is the connection arrangement given. If not given, if they mention only the number of bolts, then if they mention provide in a single row, then you have to draw this figure. So here we need to calculate what is the strength of the tension member. So as strength of the tension member, then as we know, the strength of the tension member, which is governed by three modes of failure, that is yielding of cross section area, rupture of critical section, and the block shear strength. So the three modes of failure, that is a TDZ, TDN, and TDB, we need to calculate. Out of these three modes of failure, whichever comes to be the less, that is the strength of the tension member. So let us calculate the first one considering the yielding of cross section area. So yielding of cross section area, that is we have a formula, and also it is given in a code book. TDZ equal to AZ into Fy divided by gamma MO. So here from the steel table you have to get the area of angle section. The angle is given here as 75 by 75 by 6, and double angle given. Refer steel table and section 75 by 75 by 6. You will be getting a single angle section as well as a double angle section in a steel table. If you are referring a single angle section, take the angle section area and multiply it by 2, because double angle given. Or if you are referring directly the double angle, take the double angle area. Here the double area angle is 17.32 centimeter square, that is 1732 millimeter square, because here the angles are provided back to back. Then you calculate TDZ. When you substitute all the values here, you will get a TDZ value as 393.64 kilonewton. Then second one you calculate considering the rupture of critical section, that is TDN. The TDN formula we are having uh, 0.9 ANC. This also you will get from the code book. 0.9 ANC into Fu divided by gamma ml plus beta into AGO Fy divided by gamma MO, and it is multiplied by 2 because double angles are given. So you have to multiply it by 2. So once you uh, written this formula, then you calculate ANC. So ANC is the it is for one angle. ANC is the connected leg area. So here this leg area, mark here. So this leg area, vertical, this one, this leg area for one angle. So calculate this leg area. So the leg area, that is here, this ANC is calculated as 75 minus 6 by 2 into minus 22. Minus 22 is the bolt hole here, that is diameter of bolt hole. Multiply it by 6, you will get this answer. Then calculate the gross area of outstanding leg, 75 minus 6 by 2 into 6, this one. Then calculate a beta. the value of beta, that is formula is given in a codebook 1.4 minus 0.076 w by t fy by fu bs by lc, which is less than or equal to fu by fy into gamma mo by gamma ml, and that should be greater than or equal to 0.7, where w is the outstanding leg width. And this figure is also given in a codebook, this one, refer codebook. They mentioned which is to be taken, outstanding leg width and or shear leg width. Everything is given in a codebook. So from the code you note down the formula, then substitute the values in beta equation, then you will get the value of beta. And here lc is the uh, length length of bolt line from the first bolt hole to the last bolt hole. This one, this is mentioned here, this is lc, this one here to here is a lc. Then calculate beta. Then after calculating beta, substitute the values in tdn, you will get the tdn as 392.88 kilonewton. Then you calculate the third strength, block shear strength. Block shear strength will be the avg into fy divided by root 3 gamma mo. This also will get it from the code, and here you have to multiply it by 2 because it is a double angle. For a double angle you have to multiply it by 2, and this formula is for a single angle. When you multiply it by 2, it becomes for a double angle. Then note it down, this formula. Then calculate avg, then avn, atz, atn. So this how to calculate this all explained in the first problem. Just in a similar way you calculate avg and avn, then atz and atn. Avg is the shear area that is parallel to the load, and atz is the tension area perpendicular to the load. Just mark the shear area, that is shear area means this one. So this will be the shear area to here, this is shear parallel to the load, and uh, tension area is this side, is become tension area, this one. So this length will be lv, we take in calculation of avg, and this length is lt. Lv into thickness, lt into thickness gives the tension area, lv into thickness gives me shear area. Shear area how to get, 35 plus 4 into 50, that is 200, 235. 235 into thickness gives you shear area avg, that is gross area. When you deduct number of holes, you will get avn. So similarly calculate atz and atn. Here avg is calculated here, then calculate avn, then calculate atz, atn. Substitute in the above equation, you get tdb1 and tdb2. Then the least of these two, the least will be tdb, that is this one. Then the tensile strength becomes the least of three, tdz, tdn and tdb, that is you will be getting 387.24 kilonewton. So this is for a double angle calculation of tensile strength of the member. The only change when you compare with the single angle here is you have to multiply it by 2. You have to calculate for one angle and multiply it by 2. You will be getting the strength of the member. I hope you understood this one. Then let us take a one. This is the assignment to take it. A single unequal angle 100 by 75 by 6 is connected to a 10 mm thick gusset plate at the ends with 16 mm dia bolts to transfer a tension as shown in the figure. Determine the design tensile strength of the angle, assuming that the yield and the ultimate stress of steel used are 250 MPa and 410 MPa. Here the condition given is if the gusset is connected to the 100 mm leg and if the gusset is connected to the 75 mm leg. This is the figure given. Here number of bolts given 2 4 6 number of bolts, pitch is 40, edge distance is 40, and the gauge is also given, and this is the section given 100 by 75 by 6. And the condition is, when you connect longer leg to the gusset, what is the strength of the member? When you connect shorter leg to the gusset, what is the strength? When you connect longer leg to the gusset, you have to take a G as a 60. When you take a shorter leg to the gusset, you have to take the G as 40. Here it is given. Here it is given. This one 40, 60. When 75 is connected to the gusset, 75, 100. So here in this figure, longer leg is connected to the gusset. For this, calculate the strength. When shorter leg is connected to the gusset, that time you calculate what is the strength. You take it as an assignment and solve it and practice it. I hope you understood this one. Thank you.